Hello, today we're going to work through some examples of balancing chemical equations. We must obey the rules of balancing, that the law of conservation of mass must be obeyed. We're not going to create or destroy atoms, and the only thing we're going to change is the coefficients on each side of the equation until the number of atoms on the product side equals the number of atoms on the reactant side. We're going to follow these procedures, and we're also going to follow these strategies. So let's start with the procedures. List the elements that appear on the reactant side, then copy the list in the same order to the product side. Same order is pretty important when we're trying to keep our counting straight to match up what we have. I'm going to list aluminum, and the first thing I hit is a polyatomic ion, or sulfite. Well, my tips say if a polyatomic ion stays intact, treat it like a single element. Balance this first. Let's see if it stays intact. A sulfite here, SO3 sulfite here, we can treat it like it's one atom. I go to Na is next, and I have OH, the hydroxide, and that stays intact. It wasn't broken up. So now I'm going to list them on the other side in the same exact order. That will help us with our record keeping. Next step, write the number of atoms that appear in the reactant side for each element, then do the same for the product side. I'm counting here. Aluminum, I have 2. My sulfite, I have 3 sulfites. We ignore the subscript inside. For now, we're just looking at treating it like one atom. That's all right here. Na is 1, and our hydroxide is 1. We have over this side, make sure you don't just jump to aluminum, sodium. We have aluminum. Our sulfite, we have 1. Our sodium, we have 2. And our hydroxide, we have 3 of them. Awesome. Next, choose an element to balance, making sure that you apply the coefficient to any element that are also bounded in that particular molecule. Well, our tips also already told us to balance the polyatomic ion first. So let's do that. We have and I'm going to do this part in pencil, so in case I have to change my coefficient, I can just erase it. Polyatomic ion, my sulfate. I have 3 on this side and 1 on this side. You go to the side with fewer, and I'm going to put a 3 here, and that gives me 3 molecules of sodium sulfite. So 3 times 1, I now have 3 sulfites. 3 times 2, I now have 6 sodiums. So right now our sulfites are balanced. Let's do the other polyatomic ion, my hydroxide. 3 on this side and 1 on this side. Well, you can only increase. So I put a 3 here, that gives me 3 sodium hydroxides. 3, then 3 times is 3. Awesome. 3 here, 3 here. Okay, good. More tips. Make elements with odd numbers of atoms even. Well, and also balance the binary compounds. Well, that's what we're up to. Odd numbers even. So let's make aluminum. We have 2 here and 1 here. Let's put a 2 here. So that means I now have 2 aluminums. 2 times 3, I now have 6 hydroxides. And this is a binary compound. Aluminum is 1 element, and hydroxide, we're treating it like 1 atom. So now my aluminums match, my sulfites, but my sodiums and my hydroxides do not. I have 6 on this side, only 3 here. So in this case, I will put a 6 here. 6 times 1 is 6. 6 times hydroxide is 6. So now I do record keeping. I have 2 aluminums, 2 sulfites, 6 sodiums on each side, and 6 hydroxide. I am balanced. Now, I next need to check to make sure I'm in the lowest possible ratio, because that is the last part of the process. We make sure we're at the lowest ratio. And since this is the 1 here, we can't break anything down lower than 1. And so always if you have a molecule which only has one of the molecules, we can't go any further. So we get the big star. We are checked and balanced.